Hello everyone. In this video, I want to tell you a story. And this is the story of a brilliant piece of software. And the funniest thing about it is that it doesn't even exist yet. Now, my hope is that one of you will come up with such a piece of software, a brilliant idea that is just ready to be received by the rest of the world. And when that day comes, I just need you to be ready enough to put this application, this product of yours out there without fail. This product needs to be scalable. This product needs to be as resilient as possible so that millions of or billions of users can just use it seamlessly. So let's say you end up finishing this product on your own machine and some investor comes and takes a look at it and says that this is amazing, I need this on the internet as soon as possible, put it out there, give me a URL, I will pay you for it, and just get it done. And you think to yourself that, okay, you know what, this is great, this is a good product, I need some more money, let's put it out there on the internet. What are my options? You come to me for it and I give you the options. Option number one, you have the option of having a machine of your own and self-hosting it. You could have a self-hosted server. Now the good thing is that all of the data will remain with you. It's quite private, and you just have the machine in your complete control. But the issue with it is that it is a little more complex to manage. A lot of companies, what they do is that they hire separate teams to manage these servers. Then there are other teams who actually write the business logic of the product that is to be hosted on this server. So it is that different a job. So it can be complex to manage if you are not very familiar with it. So it can be quite challenging, especially if you're a beginner and you just want to focus on your product instead of all these other things. That's one option. The second option is a little easier to work with, and those are free web hosts. So free web hosts are nothing but servers similar to these ones in point number one that are given to you by other companies. And these companies say that, okay, the server is kept with us. How about you use our website to put your code out there, host it on our server, and we'll give it to you for free, with some limitations. And you think that, okay, that's such a great idea, let's get started on that instead. Then I tell you, no, wait, just hold on for 1 second, understand the problems that you may face with it. So these free web hosts, they obviously have limited resources available. So let's say the RAM of the server will be very limited, or you will end up sharing a machine with other users who also want to deploy for free. And what will end up happening is that this limits security to a certain extent. Let's say if the machine is hacked, somebody was trying to hack one of the other users, but the machine gets exposed and your application is also under threat. So we do not want that. The resources are limited and there's only a certain number of machines that on which you can deploy for free. And there are multiple things that can be an issue for you. And what you do with these free web hosts is that you just use it for prototyping, and you just use it for personal projects just to see how your app behaves on the internet, and that is all you use it for. So you ask me, okay, then this investor wants to pay me for my software. How do I give it to him if I can't host it on my machine because it's difficult, or free web hosts don't give me as many resources as I need? So how do I then go about it? Which is what I'm about to discuss in point number three. That is the virtual private server. So a VPS, or a virtual private server, is again very similar to a free web host that is deployed on the cloud, taken care of by some other company, but you actually end up paying for whatever amount of resources you choose to use. So you have multiple options to go with over here. Very popular cloud providers are AWS, we have Azure by Microsoft, we have GCP by Google, and all of these have multiple options. And if you just want to rent out servers, plain machines, AWS has a service called EC2, Elastic Compute Cloud. Azure has their VMs, virtual machines. GCP has I think it's called a GCE, Google Cloud Engine, if I'm not wrong. Then these are some services available for you to consume. Of course, you will end up paying for them. The more they are being used, the more you pay for them. Now, you say that, okay, but you know what? How about I just start with the free web host? What is so wrong with that? Like I said, for prototyping, it is perfectly fine. You go ahead, you use it. But what happens when an influencer comes to your website? They like what they see. They like to make content about everything under the sun. They're like, okay, I want to cover this website for my Instagram page. They make a video on it. The video goes absolutely viral. Thousands of likes on it, lots of comments. People are rushing to visit your website. Do you really think a free host with limited resources will be able to handle all that traffic? I don't think so. So VPSs offer you the option of easily, very, very flexibly scaling up or down. I've written down a word here, scaling. If you know what it means, great. If you do not know what it means, you're in the right place, because that's what the title of the video says anyway, right? We are here to discuss scaling. So what do we actually mean by scaling? Scaling is divided into two parts in my definition. The first type of scaling is vertical. What does vertical scaling mean? Vertical scaling means that you take one machine, let's say it had 1 GB of RAM and 128 GB of memory or storage capacity, and let's say 1000 input output processes per second. As soon as your website starts getting more and more and more traffic, you realize that, okay, my RAM is getting filled up very fast because of the number of tasks that it has to deliver. So you say, okay, how about I increase my RAM from 1 GB to 4 GB, or my memory from 128 GB to, let's say, 256 GB. Or if I had an HDD disk in my as my storage device, I want to move to something called an SSD, which is probably present on your own device that you're watching this video on. Or I want to increase my IOPS from 1000 to 3000. You just want to use one machine but have it handle more intense tasks. You want it to have more capacity to handle all this traffic. That's vertical scaling. So you say that, okay, you know what, that's a great option. If VPSs allow me to scale vertically, I will simply do it. What is the harm in that? Well, just listen to me. There is a bit of a catch. Catch number one: there are limited resources. Once again, you will eventually hit the ceiling of what hardware is available to you. A lot of providers will have a certain cap. Let's say some may say that, okay, you know what, I can't give you a machine that has more than 32 GB. Or some will say that, oh, you know what, okay, 2 terabytes of RAM, that's the most I can give you, which is a lot of RAM. But you have to realize that we will hit the ceiling not only in terms of hardware, we will also hit a ceiling in terms of money, because a 2 terabyte RAM machine may be available for you, but it will be quite expensive. We cannot afford that, especially if our app is just getting out there in the world. That is simply not an option for us. So you ask me, okay, then fine, what do I do? What is the alternative? That brings me to the second type of scaling, which is horizontal. So just to differentiate, in vertical scaling, we have multiple clients, people who are on their own computers. They're opening up our websites on different devices over here. We have this one server. All the requests come to it directly and it returns a response to each of them as soon as it can. Okay, that's our server. But in horizontal scaling, what we end up doing is that instead of getting one big machine with 16 GB RAM, 2 terabytes RAM, whatever it may be, we choose to have a lot of cheaper machines that have smaller capacities. So let's say instead of one machine with 4 GB RAM, I get 4 machines that have 1 GB RAM each. And that would be a little cheaper for me in the long run. So that is basically what horizontal scaling is, that instead of choosing to increase the capacity of the one machine that we're using, we end up having multiple cheaper but smaller machines to distribute our workload in a much more efficient manner. So what will end up happening is that we still have all these computers that are trying to access our application, but this time we have multiple servers to handle this workload. But you may ask, okay, then which computer will send a request to which machine? We don't know how are they connected. That brings me to this challenge, that okay, you know what, sure, this is cheaper, this seems easier to implement, that you know what, whenever there is more traffic, just increase the number of machines and we're good. But there is a little bit of added complexity to that. You will need something called a load balancer in between. This load balancer will take up all the requests, and it will be the one to decide which of these servers get which of the requests sent by our clients. These are, of course, our clients over here, and these are our servers. So load balancer is the one that decides what we are supposed to do. All right. So how would load balancers decide which servers are to be sent a request to? Now, of course, I will go into depth of load balancers in a separate video, but just to give you an idea about how horizontal scaling can be done in practice, load balancing can be done in multiple ways, a few of which could be, let's say you have your HTML files deployed on one machine, you have your logic deployed on another machine, your business logic, your API, all right? You could have your assets, let's say your images or videos that your website is using, that could be on a different machine. So when a client requests for an HTML page, you go to this server. If they're asking for some process to be done, you go to this one. If they want to view an image, you go to this one. That is how load can be balanced. Or you could be a little smarter about it and have all three of these things on all of the servers, but you use the load balancer to send a request to the least busy one based on certain metrics. Let's say whoever's RAM is least used right now, you can send a request to that one and return the response, and so on and so forth. Or number three, you could do something like a round robin approach. I'll just write it down here. Round robin. So let's say first request comes in, it goes to machine number one, second one goes to machine two, third goes to machine three, fourth goes again to machine number one, and it goes on in a round robin fashion. So that's basically horizontal scaling for you. And now that I have explained to you in brief about the two types of scaling, I will compare the two now just to give you a better insight on when we use either of the approaches. So we have a few metrics over here in this column over right here, and we have horizontal scaling, vertical scaling. We have to compare the two. So in terms of concurrency, number of requests that can be handled at the same time, to put it very, very simply, how does horizontal scaling work? Well, since we have a load balancer and different machines, we can handle multiple requests with the help of load balancing. But when it comes to vertical scaling, concurrency can be handled by multi-threading. So you should be proficient in multi-threading. Your application should be able to handle that is. So you'll have to be very good at what you code to basically handle concurrency well when you are trying to scale vertically. As far as load balancing is concerned, you just need to increase the number of machines. As long as you know how to manage those machines, scaling will not be an issue for you. Your application's logic will remain quite simple. Complexity. Here, complexity can be a little more because, like I said, you have to use load balancing over here, right? Implementing a load balancer, especially in the beginning, is not that simple. So complexity can be a bit high because of that. As compared to that, complexity in vertical scaling is low because you just have one machine, your application is deployed on it. You don't need to have a distributed architecture to take care of it. And that basically makes things a little easier for you as long as you can afford to increase your resources by paying a little more. Downtime. You have very less downtime in horizontal if you implement horizontal scaling because you have multiple machines taking care of tasks for you, right? So even if one machine goes down, the others are there to take care of it. And if you compare that to vertical scaling, you just have one machine. You have something called a single point of failure. So if this machine goes down, if you don't have a backup machine, everything falls apart. Your website is simply not accessible to the users, and that ultimately is not best for your brand, for your business, right? So this is a single point of failure, and vertical scaling, that is basically the cause of more downtime, at least as compared to when you scale horizontally. Cost. In the beginning, cost may seem high at first, but as you scale, it becomes lower and lower. And vertical scaling feels good in the beginning, so the exact opposite of this. At first, it is low, but when you choose to scale up, hardware gets more and more expensive, so it becomes high later on. And now, in terms of performance, performance is very subjective, it depends on the application. But overall, if you look at it, horizontal scaling tends to perform better because distributed architectures, as complex as they are more resilient, so less downtime, as I already mentioned. And there are multiple machines, right? There are multiple machines, so your workload is distributed across these machines, but that is not the case with vertical scaling. So performance can be hampered, and especially when traffic is high. And that basically covers all the points that I want to talk about in this video, where we compare horizontal scaling with vertical scaling. And we'll talk about more such system design concepts in this very on this very channel. So just stay tuned and follow for more, and I'll see you in the next one.